Hi, so for this video, I'll be discussing about different theorems related to arcs, chords, central angles, and inscribed angles. Okay, so let's start with theorems on central angles, arcs, and chords. So the first one is, in a circle or incongruent circles, two arcs are congruent if and only if their corresponding central angles are congruent. So check the given circle on the right. So this is circle R. So remember that we name circle based on the letter assigned to its center. So here we have R, so it's circle R. Okay, so the first theorem says that if you have two central angles and they're congruent, then the corresponding arcs to it are also congruent. So looking at this circle here, so we have two central angle here. We have angle ARB. Let's mark it. So angle ARB and angle CRD. Okay. Okay. So if these two angles here are congruent, we can also say that the corresponding arcs to it, which is arcs AB and CD, are also congruent. Okay, so let's write a statement for it. So if angle ARB is congruent to angle CRD, then we can say that arc AB is congruent to arc CD. Okay, so that's the first one. Let's have the second one. Okay, so in a circle, or again in congruent circles, two arcs are congruent if and only if their corresponding chords are congruent. So let's use the same circle to represent this. So if we have two chords, for example, so let's make a chord here. Okay, so we have here chords A, B, and C, D. Okay, so based from the theorem, if chords A, B, and CD are congruent, then arcs AB, okay, is also congruent to arcs CD. So let's also write a statement for that. So if based from the second theorem, if you have two chords that are congruent, so here we have chords AB and chords CD, okay, then same thing, arcs AB is also congruent to arcs CD. Okay. Okay, let's have the third one. In a circle, a diameter bisects a chord in an arc with the same endpoints if and only if it is perpendicular to the chord. So let's have circle F here. Okay, so as you can see, AB is the diameter of the circle, and we have LM here, which is a chord. Now, based on the given theorem, if the diameter is perpendicular to the chord, so let's say this is perpendicular, okay, so it forms a right angle, okay, then we can say that it bisects both chord LM and arc LM. So Let's make some markings. So therefore, LP is congruent to PM. They have equal measure. The same thing with arc AL and arc AM. Let's write a statement for that. Okay, so again, if LM, which is a chord, take note, is perpendicular to AB, so just remember that one should be a chord and the other one should be the diameter of the circle. Then, okay, two things will happen. LP is congruent to PM and arc AL is congruent to arc AM. Okay, so take note with the word bisect there, means it divides them equally. I forget to mention that. Okay, so that is for the third theorem. Let's have the fourth one. The measure of a central angle is equal to the measure of its intercepted arc. So from the previous video, we already defined what an intercepted arc is. So here, let's have angle SKL. So angle SKL is a central angle, okay? So it's a central angle, and its intercepted arc is arc SL, okay? So now, based from the theorem, the measure of the central angle is equal to the measure of its intercepted arc. So angle SKL has the same degree measure with arc SL. So if, for example, angle SKL is 35 degrees, then arc SL is also 35 degrees. They have the same measure. Okay. Now let's have the fifth one. Chords equidistant from the center of a circle are congruent. So the word equidistant here, it means equal distance. Okay, so let's use circle P here to show this theorem. So we have here chords AB and chords CD, and it's connected to the center of the circle, so point P, by segment EP and segment PF. Okay, so based from the theorem, the chords AB and chords CD will be congruent if they are equidistant from the center. So it means that if EP is congruent to PF. Okay, so let's just write a statement. So if EP is congruent to PF, then chords AB is congruent to chord CD. Okay. Okay, so now let's have theorems on inscribed angle. So number one, the first one, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. Or we can say that the measure of the intercepted arc is twice the measure of the inscribed angle. So take note of twice the measure of the inscribed angle. So let's have a circle S here. So as you can see, angle ARB is an inscribed angle. Okay. Now, based from the theorem, so the measure of its intercepted arc is double the measure of the inscribed angle. So if angle ARB is x, for example, then the measure of arc AB is 2x, twice the measure of the inscribed angle. So let's put a measure, for example, if we say that angle ARB is 20 degrees, then the measure of arc AB, twice of that, is 40 degrees, as simple as that. Okay. Okay, second term, if two inscribed angles or more, okay, of a circle or congruent circles intercepts congruent arcs or the same arc, then the angles are congruent. So let's find first the inscribed angles here on circle A. Okay, so we have here angle CBD. Okay, so angle CBD is an inscribed angle and it intercepted arc CD. Okay, this arc. Okay, now if you check angle CFD, this one, angle CFD. Okay, angle CFD is also an inscribed angle and it also intercepts the same arc, which is arc CD. So you can check it by finding the endpoints of your angles. Okay, so as you can see, CD. And the same thing with angle CED here. Okay, angle CED is an inscribed angle which intercept the same arc, arc CD. Okay, so the three inscribed angles here, angle CBD, angle CFD, and angle CED, intercepted the same arcs. So because of that, we can say that these three angles are congruent. Okay, so it's also easy to find out by checking the name of your angle. So let's write the name of the angle here as a guide for you also. We have angle CBD. The other one is angle CFD. And then angle CED. Okay. So as you can see, the endpoints are both CB for all the three angles here. We have CD here, CD also, and CD there. Okay, so just remember that it should be an inscribed angle for you to use this rule. Okay, now can we find other equal angles using the same using this theorem? So let's check angle FCE. Let's mark it so you can see FCE and angle FDE. Okay, so these two angles intercepted the same arc, which is EF. Okay, this arc. So you can see clearly, let's write the name of the two angles, angle FCE and angle FDE. Okay, so as you can see, you have F and E, F and E there. Okay, so we can say also that these two angles are also congruent. Okay. Okay, now the third one. If an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. So as you can see here, we have circle L and angle NIK is an inscribed angle. And it intercepts arc NK this one. So arc NK here is a semicircle, okay? So since this is a semicircle, so based from the theorem, the inscribed angle NIK is a right angle. Okay, this is obvious also using the previous theorem that we have, that the measure of the inscribed angle is half the measure of the intercepted arc. We know that a semicircle measures 180 degrees, right? So therefore its inscribed angle will be 90 degrees, which is a right angle. Okay. Okay, let's have the fourth one. So if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So quadrilateral inscribed in a circle, we also call it a cyclic quadrilateral. So let's take note of that. So quadrilaterals inscribed in a circle. So if you read some books, you will see the word cyclic quadrilateral. They mean the same thing. It means that the vertices of your quadrilateral lies on a circle. Okay, then its opposite angles are supplementary. So when we say supplementary, the sum is 180 degrees. Okay, let's have here a circle. Oh, we didn't name it, so let's put P, for example. So let's have here circle P. Okay, now based from the theorem, so opposite angles of a cyclic quadrilateral is supplementary. So since we have here a quadrilateral, which all vertices inscribe on circle P, then we can say that angle X and angle V, which are opposite angles, are supplementary. So angle X plus angle V is equal to 180 degrees. The same thing with angle W and angle Y. Okay, they are also supplementary. Okay. Okay, let's apply what we have learned to this circle. Let's find the measure of the given variables here. So for the first circle, circle O, let's find the measure of angle X, Y, and Z. Okay, so we are given here the measure of angle AOB, which is 100 degrees. Okay, now using that, so let's see. Angle AOB is a central angle. So since this is a central angle, so meaning it is equal to the measure of its intercepted arc. So here we have um, angle arc AB. Okay, so this one also measure 100 degrees. Okay, so I did that because as you can see angle Z, okay, angle C and angle Y here, okay, intercept the same arc, which is angle arc AB. Okay, so based from the theorem that we have learned, if you have an inscribed angle and it intercepted the same arc, so the measure of the inscribed angle will be half the measure of its intercepted arc. So the intercepted arc is 100 degrees, so therefore your angle Z and angle Y is 50 degrees, half of that. Okay, so we already have angle Z and angle Y. Let's find angle X. So we can use a different concept here to solve for angle x. I'll be using cyclic quadrilateral. So we know that if you have a cyclic quadrilateral, opposite angles are supplementary. So let's mark here the quadrilateral that I'll be using. This one. Okay, so I'll be using this quadrilateral here. Okay, it's a cyclic quadrilateral. Okay, so opposite angle x is angle y, and we already got the measure of angle y, which is 50 degrees. So they are supplementary. So it means that angle x plus angle y is equal to 180 degrees. And we know that angle y is 50 degrees. Okay, so 180 minus 50 is 130. So therefore angle x is 130 degrees. So we have here all the three measures that we want. Okay, let's have the next circle. Oh, it's a circle O also. Okay, we have here also a cyclic quadrilateral. Okay, so what I will do is I will use the opposite angles. They have the same variable here. So we can solve for the value of x using the concept of a cyclic quadrilateral. So the sum of the two opposite angles is 180 degrees. So solving for that, so x plus 3x is 180 degrees. Again, why? Because they are opposite angles and they are on a cyclic quadrilateral. So solving for this, you will have x plus 3x is 4x is equal to 180. Divide both sides by 4. Your x is 45. Okay, so therefore this one is 45 here. And 3x, so that is 3 times 45, which is 135. So this is 135 degrees. Okay, now how can we solve for y and for your z? Okay, so as you can see here, angle y is a central angle and it intercepted the same arc as angle x. Okay, so angle y and angle x intercepted the same arc, but angle y is a central angle and angle x is an inscribed angle. So since our angle x is 45 degrees and the measure of its intercepted arc will be twice of that. So if that is 45 degrees, then this arc here, okay, that one is 90 degrees, right? That should be 90 degrees. So the intercepted arc is equal to the measure of your central angle. So therefore, angle y is, oh, I forget to put angle x here. Oh, sorry, there's no need. So your angle y is 90 degrees. Okay, then it's easy to solve now for your angle C. So this is 360. Okay, so 360 minus your y, okay, which is 90 degrees. So therefore your angle C, let's put it up, your angle C is 270 degrees. Okay. And then the other two measures are on the figure. Okay, Now it's your turn to try solving the following circles. I want you to find the measure of the assigned variables here. So you can pause the video first, try solving for it, and then once you're done, you can continue so that you can see um, the answers. Okay. So these are the answers. So for the first one, angle E is 108 degrees. Angle D is 36. And angle F is 54. For the second circle, angle Y is 145 degrees, and then angle Z is 290 degrees. Then for the last circle, you have angle C is 44 degrees, and angle D is 46 degrees. Okay. I hope you got the correct answer. Thank you for watching this video. Till next time. Bye.